This is a brief tutorial to understand quantum mechanics and how it might relate to the mind-body problem that we've been discussing in our part 3 here of the series, What It Means to Be Human. Now, quantum is a Latin word for the smallest amount of physical quantities, matter or energy. So quantum mechanics is a science that seeks to understand how matter and energy work at that very smallest possible scale at the subatomic level. In fact, quantum mechanics is often referred to as the foundational science that will eventually explain everything. In our current series, What It Means to Be Human, we are attempting to understand human consciousness and how quantum mechanics may hold the key to that. Now, as we saw in part 3, the human observers, Alice and Bob, they participate with the atomic structure of matter and the laws of quantum mechanics that describe that interaction. That's mind-blowing in itself. Materialism has no answers for this phenomenon. It just assumes that evolution will somehow provide that. But this assumption is unsatisfactory to modern physics, which affirms the reality of the essential participation of the observer with the observed. Biology has neglected the observer's participation in events and has relied exclusively on materialistic evolutionary models. Sir Roger Penrose, Nobel laureate, put it this way: consciousness is part of our universe. So any physical theory which makes no proper place for it falls short of providing a genuine description of the world. Okay, well, how might quantum mechanics now help explain the mind-body problem? To review briefly, in parts 1 and 2, we saw that we have two basic mental states. One views an object through our senses from the outside into our brain. That perspective is called our objective view. But there's another view going on inside my mind here. That's the mind's eye understanding of what is going on outside. That's what we call our personal view. Two views of reality: objective inside out, personal view outside in. Now, how might quantum mechanics explain these dual mental experiences? How might quantum mechanics explain communication between these two dual states? Now, to get a handle on that, we have to go back to classical physics. Take you back to your high school physics class, classical physics, and Sir Isaac Newton. In classical physics, objects, including human beings, are explainable as molecules in motion. Everything's made up of molecules in motion. And at any one point in time, every particle, living and non-living, has a definite mass, position, and speed, which we can calculate using Newton's laws of motion. Now, these classical equations serve us well at the level of at the scale of our human existence, even got us to the moon. But at the subatomic level, way down where things are tiny, 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 trillions of the size of a hair, things behave bizarrely differently. The quantum mechanic equations talk to us in terms of probabilistic outcomes, uncertainty principles, wave equations. Objects are just not particles in motion, but also waves in motion. Objects have a dual nature. More bizarrely, we need to observe these wave particles to determine their actual physical manifestation. We actually participate with nature in observation. Before observation, we have waves that spread out over time, but at the time of observation, particles localize into a space-time event. Now, at the quantum level, objects can literally be at two places at one time. One place called the local state and another place called a non-local state. And properties of the two particles that operate in those two different states, the properties are viewed as one single property, regardless of how far apart they are physically, even millions of miles away. This strange phenomenon we call quantum entanglement. Einstein called it spooky action at a distance. Even though it's counterintuitive, it is proven science. and we are sure of its mathematics. Now, nature and the quantum mechanics that describe it is a lot more mysterious than we can ever imagine. It's a product of the observer and the observed, and they become entangled in some strange way. Nobel laureate and one of the discoverers of quantum mechanics 100 years ago, founders of the theory, put it this way: if quantum mechanics hasn't profoundly shocked you, you haven't understood it yet. Quantum mechanics will be instrumental in any understanding of consciousness and the dual nature of reality, including ourselves.